So I'm not sure who your Calculus 1 professor was, but you should have learned U substitution in Calculus 1. But I find that some students still need a little bit of help with it. And so therefore, I want to cover just a bit about U substitution and do it with some definite integrals. Okay, so something very basic. If you remember the chain rule, so U substitution comes out of the chain rule. So if you remember the chain rule, so the chain rule says if I want to take the derivative of y with respect to x, well, it depends on what my function looks like. Okay, so if it's a regular function like the sine of x, then the derivative of y with respect to x, that's not what I meant to write. I meant to write of the sine of x is cosine of x. But if I take the derivative of y with respect to x of the sine of x squared, we know we're going to get the cosine of x squared, and then we have to multiply by 2x, which is the du dx. So this is the chain rule. So given y equal to y of u of x, then the derivative of y with respect to x, we find the derivative of y with respect to u, and we multiply by du dx. Okay, so basically it is that the derivative of y with respect to x simply becomes y prime at u du dx. So now let's integrate that. Okay, so if I want to integrate that, here I have the integral of dy dx dx is the integral of y prime of u du dx dx. So that simply becomes the integral of y prime of u du. So it assumes that we are integrating or trying to find the antiderivative of a function. So I need the antiderivative of this. Of y prime, and we know that's just equal to y, but it assumes that the derivative of the inside function is sitting right next to or part of the integral. So it assumes here that du is sitting next to y prime of u. So in order to integrate this, I basically will then find y of u plus a constant. Now we've all done this. This is actually rather easy. Okay, so I want to integrate the integral of x cosine of x squared dx, and this is the cosine of x squared. So x squared is the argument. So we let u equal the inside function x squared, and then we find du to be 2x dx. So now, when I look at my problem, I have cosine of x squared. That piece, the cosine of x squared, that's pretty easy. That just becomes the integral of the cosine of u, because x squared is u. But what I still have left is x dx. And so I need to solve for x dx. So x dx is 1/2 of du. So now for x dx, I can put in 1/2 du. So now I have completely substituted everything in my problem. And so this becomes 1/2 the integral of the cosine of u du. So now it's a function of only one variable, okay? And the variable is simplified, it's just a cosine of u. I can integrate the cosine to get 1/2 the sine of u plus a constant, and then I need to substitute back. So this is 1/2 the sine of x squared plus a constant. Okay, so is there anybody that needs additional support or help with understanding u substitution? How about I give you an example to do? Okay, so how would I integrate that? I'll give you guys a few seconds to think about it. The first thing you need to do is identify u, and you have to make sure that when you identify u, you see the derivative of u somewhere in the problem, and it cannot be in the denominator.
Can u be x squared?
Okay, so if u is x squared, then what's its derivative?
2x.
Okay. Now, one thing you need to remember is that 2x dx, that x dx is stuck with each other, so it can't be separated. X dx is stuck with itself. Okay, and how am I going to get x cubed plus 2 from this?
You can use the chain rule.
Okay, we are going to use the chain rule. We're doing it backwards though. So my question to you is, u always has to be a function where its derivative is present. So if u is x squared, the derivative, which is 2x dx, I don't see that in my problem. Ezekiel, do you see why we're having trouble with that?
Yes, I can see it.
Okay.
Mainly the denominator is what's affecting it.
So let's let the denominator be u. So let's let u just be x cubed plus 2. Okay, so now that u is x cubed plus 2, what is the derivative of u?
3x squared.
3x squared.
Okay. So differential. So if I have du, it becomes 3x squared dx. Okay, so now I'm feeling pretty good. And the reason why I'm feeling pretty good is because, oh my God. I'm feeling pretty good because here is x squared dx. I'm liking that. You see it? And here is x squared dx. So now I can solve for that. So I can now see that 1/3 du is x squared dx. So now I know what x squared dx is. It's 1/3 du. And I know that x cubed plus 2 is just this, which is going to be u. So I'm going to make a direct substitution. So this is the integral. I still have a 2. X squared dx is now 1/3 du. And then in the denominator, how about I just have u to the 4th power? So now I can pull out my 2/3, the integral. This is going to give me u to the -4 du. So now I just find the most general antiderivative. And so that's going to be u to the negative. I'm going to add 1. So that's going to be u to the -3. Then I'm going to divide by -3. And I still am multiplying by 2/3. Plus a constant. So now I get -2/9. And then u to the -3 is 1/u cubed plus a constant. So my problem answer is -2 divided by, and the denominator is 9, and x cubed plus 2 to the 3rd power plus a constant. And that is u substitution, my antiderivative. Do we need another example?
Yes, please.
Okay, so u, as always, is the most complicated thing in the problem. So what is u going to be?
15 minus 6x squared.
Okay, And then du is what?
A negative 12x.
Keep going.
Oh, negative 12x dx.
Dx, good. We need that dx. Okay. So when I do my integral, I get the integral. So 15 minus x squared is in a square root, which means it's being raised to the 1/2 power. So I'm just going to write that as u to the 1/2. So this u to the 1/2 is this thing. And what's left is x dx. So I need to solve for it. So x dx is negative 1/12 du. Okay. So now I can prove the minus 1/12 out, the integral of u to the 1/2 power du. So I have negative 1/12. And then I'm going to get u. I'm going to add 1 to the 1/2. That's going to give me 3/2. And then I'm going to multiply by 2/3 because I'm actually dividing by 3/2, which means I multiply by 2/3 plus c. So now I get minus 1/18. U is 15 minus 6x squared to the 3/2 power plus a constant. Okay, any questions about that? Any questions?
Hi, Dr. Locke.
Yes.
Would you kindly go back to the part where we got negative 1/12 du or dx?
Okay, so I was here, I had du is equal to negative 1/12 x dx. So I took du and divided by negative 12. And I took negative 12 x dx and divided by negative 12. So these divide out. How's that feel?
Nope, thank you.
You're welcome. Okay. So I'm gonna throw a little bit of the next section in here for a minute. So therefore, if we recall, oh, we didn't do that yet. I didn't teach you that yet. I got to teach it to you. Let's do, so all of those were indefinite intervals. So now we're going to do a definite interval. Okay, so what's different about this problem?
It's giving you, I want to say interval.
Okay, good. I gave you limits of integration because I'm actually trying to find the area under the curve between 0 and 1. So I have given you an interval, 0 and 1. Okay, so now what we're going to do is we're going to do our U substitution. However, we're going to have to not only transform our x's to u's, we're going to have to transform our limits as well. Okay, so now we're going to get a little bit more work. All right, so this is what we're going to do. What is u?
X squared plus 8.
X squared plus 8. And du?
Uh,
2x dx.
2x dx. Now this one happens to be perfect. I have 2x dx, so I don't need to do anything. Here's 2x dx right there. So I don't even have to divide for this one because I already have it. 2x dx is perfect. Okay, so now that's going to substitute. Here's u. U is x squared plus 8. So that's going to substitute here. But I need to do something with my limits of integration. So now I have to say if x is equal to 0, then u is equal to 8. And if x is equal to 1, then u is equal to 9. So I use u. So I went from x space to u space. Any questions about going from x space to u space? Okay, so now my integral is going to be the integral when x is 0, u is 8. And when x is 1, u is 9. So I have to change my limits of integration. They have to coincide with my new problem. 2x dx is du. And that is over the square root of u. So this now becomes the integral from 8 to 9 of u to the negative 1/2 power du. Now, notice everything is in terms of u. Nothing's in terms of x. I don't have to go back to x at all. I'm completely in u space. So I'm going to take u to the 1/2. I'm going to u to the negative 1/2. I'm going to add 1, so I get 1/2. I'm going to divide by 1/2. That means I multiply by 2. And now I have to evaluate this between 8 and 9. So this is going to give me 2. When I put 9 in there, I get the square root of 9. Well, that's 3. And when I put 8 in there, I get the square root of 8, but that's 2 to the root of 2. So there's my answer. Okay, I'm gonna do another one. So the problem we're going to do is the integral from 0 to pi over 3 of the sine squared of x times the cosine of x dx. Okay, now we just have to remember that the sine squared of x is just the sine of x squared. Okay, so what are we going to let u be?
I want to say sine x.
Good. And then du is
Cosine x
cosine x what?
dx.
Dx. Okay, so when x is equal to 0, u is equal to the sine of 0. So what is u? What's the sine of 0?
1. Oh, wait, I'm sorry, 0.
Okay. And then when x is pi over 3, u is the sine of pi over 3, and that is you guys must not have that calculus equations and answers that I told you to get, because all of these are on there.
The square root of 3 over 2.
Square root of 3 over 2. Y'all are going to be wishing you had it for the test. Okay. So now this becomes the integral. 0, u is 0. Pi over 3, I get the square root of 3 over 2. Sine of x is u, so I get u squared. And cosine x dx is just du. It's just that simple. Okay. Can you please finish the problem?
So in this, so now you have to, is the word implement? I don't know if that's the right word, but
Integrate.
integrate. Okay. So in this case, we have u squared, and it will change to sine x squared.
Okay, integrate u.
And
Don't put x in, and you don't ever need to use x again.
no, I wasn't using x. I was actually, because we have u equals sine x.
Okay, so
gonna-
once we get to this point, we don't ever go back. We're done. Okay, we are done with x. We never go back. There's no more sine. There's no more x. There's no more cosine. There's no more pi over 3. They're all gone. We removed them and came to a new problem. That was the point of doing the u substitution, was so that we could substitute out all the difficult parts that involved involved x, and then come to an easier problem that only involves u. So once I've done that, I do not go back. This is a one-way process. Okay, so now we're moving forward this way. We cannot go back. So this is now 1/3 u cubed. Evaluate between 0 and the root of 3 over 2. It's just that simple. One-way process. DR,
Sorry, yes.
do you get that?
I'm trying to see how you got 1 cubed. I'm guessing you got it from
It was u squared, so I added 1, that gave me u cubed, and I divided by 3.
okay. I get how you got that.
Okay. So now this is 1/3 this is the root of 3 over 2 cubed minus 0. So I get 1/3. I'm going to get 3 to the root of 2, 3 to the root of 3 over 8. The 3's are going to divide out, so I get the root of 3 over 8. And I'm done.
Do you mind explaining how you got 1/3 again?
Okay. If I had the integral of x squared dx, what is that going to give me? Remember, the integral of x to the n dx is x to the n plus 1 divided by n plus 1 plus a constant.
Could I have a go at it?
Yes,
So the integral of x squared dx, would that be 1/3 x cubed plus c?
right. So the only thing I did was I did it in u instead. So instead of me doing the problem here, the problem was in u. So I just took you back to, let's remember when we integrated x squared, we got 1/3 x cubed. So if I integrate u squared, I get 1/3 u cubed. Where does the 3 come from? Where I had x squared became x to the 2 plus 1 over 2 plus 1. So the integral of u squared du is the same thing except the variable is u. So I get 1/3 u cubed. I don't have plus c because I have a definite integral. So therefore, I have limits as such.
Okay, thank you. I understand now.
No problem.
Excuse me, Dr. Long. Are there any exceptions to the rule that's for integrals by chance?
I'm sorry, I can't hear you, Victor.
Are there any exceptions to the rule that of integration by chance?
There's one exception.
One exception. Okay.
One exception. And I was going to teach it to you. I'll go ahead and teach it to you now. So here's the one exception. We get the integral of x to the n dx is equal to x to the n plus 1 divided by n plus 1 plus a constant if n is not equal to -1. If n is equal to -1, then the integral of x to the -1 dx is just the integral of 1 over x dx. And the integral of 1 over x is the log of the absolute value of x plus a constant. So there's the exception. Okay. So the integral of 1 over x dx is the log of the absolute value of x plus a constant. And that means the integral of 1 over u du is the log of the absolute value of u plus a constant. Okay, any questions about that? Well, let's use that. I want to compute the integral of 2 over 4x plus 3 dx. So now I'm going to let u equal 4x plus 3, and du is going to be 4 dx. So dx is 1 over 4 du. So this now becomes the integral. Let's pull the 2 out. Dx over 4x plus 3 so I get 2 times dx is 1 over 4 du, and 4x plus 3, well, that's just u. So now I get 1/2 the integral of du over u. Oh, well, that's what we just learned. The integral of du over u is the log. Oh, I forgot my 1/2. The log of the absolute value of u plus a constant. So my answer is 1/2 the log of the absolute value of 4x plus 3 plus a constant. So Victor, the only exception is when it is du over u. I can have u to the any other number but -1. Then I will add 1 and divide by it. But if it ends up being du over u, I'm going to get the natural log.
Thank you.
Okay. Compute. The integral of x Okay. What is u?
Can we let u be 3 minus x squared?
3 minus x squared. So what's du? Victor, what's du?
Du would be 2x or 2
Don't forget the negative.
yeah, negative 2d.
Okay. So now I have x dx. I see that. All right, so I can say that x dx is going to be -1/2 du. I divide both sides by -2. Okay, so now I need to do my u is equal to 0. Sorry, when x is equal to 0, u is 3 minus 0, so that's 3. And when x is equal to 2, u is 3 minus 1, which is 2. Sorry, when x is equal to 2, u is 3 minus 4, which is -1. Okay, everybody with me? Anybody need any more clarification?
So Dr. Lott, if I understand correctly, the U values that you get are basically from substituting the X values onto the U equation?
Substituting the x values. So remember, these right here are limits of integration on x. So we substitute those in to find the limits of integration on u. And they go into at the top. So if x is 0, u is 3 minus 0.
Yep, I got it. Thank you.
Okay. And if x is 2, u is 3 minus 4, which is -1.
Thank you.
So this now becomes the integral. Remember, one way, don't go back. When u is 0, when x is 0, u is 3. And when x is 2, u is -1. X dx is -1/2 du. And 3 minus x squared is u. So I get -1/2. The integral from 3 to -1 of du over u. Well, that's -1/2 the natural log of the absolute value of u. Evaluate it between 3 and -1. So this is -1/2. I'm going to get the log of the absolute value of -1 minus the log of the absolute value of 3. So I get -1/2. The log of absolute value of -1 is the log of 1, but the log of 1 is 0. So I get 0 minus the natural log of 3. So I end up with 1/2 the natural log of 3 as an answer. So we learned a couple of things today. The first thing we learned is, well, we reviewed actually u substitution. And then we actually learned that the integral of du over u is the log of the absolute value of u plus a constant. Now, what we're going to learn tomorrow is the integral of e to the x dx is just e to the x plus a constant. So therefore, the integral of e to the u du is just e to the u plus a constant. So that's going to be where we're going to work tomorrow, right there. And I will put the review sheet up. I'm pretty sure I have a review sheet. Okay. Any questions?